today we are going to discuss about AWS code pipeline for Lambda with Terraform. So before we go into the solution, let me bring up with the problem statement. While you're working with infrastructure as a code using Terraform, and have you ever came across you or your team is an immense pressure from application teams in regards to create a reusable modules where you want to reuse the same component again and again that would fit into many application teams? Or have you ever came across where you want to share your infrastructure as a code to your peers or other teams in your organization for extending the current functionality of the module? Or have you ever wondered how to create an AWS code pipeline that can deploy your application code, any code that is Dockerized, to AWS using Terraform? You have come to the right video. In this video, with the help of Terraform, I'll show you how I have implemented modules for AWS code pipeline and supporting AWS services like AWS codebuild, code commit, and AWS ECR so that you could provision infrastructure that will create a pipeline and that will further be used to provision and deploy Lambda code into AWS. So since provisioning Lambda is a very easy way to show this demonstration, I have chosen a sample Lambda code, but you can adopt this approach for provisioning any container services in AWS. Okay, so since we are reviewing the high-level design document, let me walk you through this document so that we could understand what exactly we are doing here. In this document, what we are seeing here is a developer applying a Terraform apply command, and which is basically provisioning this code pipeline. And what is in the pipeline is basically two stages. One, a Lambda function, which is Dockerized, which is going to be compiled and push it to ECR repo. In the second stage, we're going to use the same ECR image with the help of codebuild being pulled and then provision the infrastructure or provision the AWS Lambda using Terraform. All right, since we reviewed high-level design document, let me walk you through the folder structure and files that are essential for you to understand for customization. Okay, so this is my code pipeline for Lambda using Terraform repo, which you could also check out from GitHub. I'll be sharing the GitHub repo URL in this video section. For now, let me walk you through the module section in the Terraform. So this Terraform folder is the one which is responsible to provision the infrastructure. Okay, so if you see here, there are a couple of modules, which is code commit, which is used for us to push our AWS Lambda code for allowing the pipeline to compile the Lambda code. And two, the code pipeline itself, which is used to basically build the pipeline. And also, this pipeline module will be having multiple files in it. Okay, and those files will be reviewing it. So when talking about the files, in each module, there are mainly three files which we need to understand. The main.tf, which is a core logic for our modules. And two, there's a variables, which is the one which is used to define what all variables goes into our logic of main.tf file, and ultimately the outputs.tf, which is used as an output section of our module. So this is code commit and code pipeline. Within code pipeline, you're seeing a bunch of other Terraform scripts, which is basically used to help us provision the infrastructure of code pipeline using Terraform. And same goes with the ECR. And there are a bunch of other Terraform scripts at the root folder of Terraform folder, which is main.tf, outputs, providers. So in addition to the Terraform module, there is another folder called lambda_bootstrap. So which is mainly used to provision the Lambda application after our code pipeline is created. So what we will do is, once the pipeline is created, we're going to check in this bootstrap folder into that particular code commit repo so that our pipeline will take that repo and compile the code and build the Docker image and finally push it to the ECR. All right, so let's go a little deeper into the code base so that we would understand the high level of each and every file that we have written here. And then we'll finally able to provision the infrastructure in AWS. So let's start with the supporting files first, and then we'll go into the main logical files. The supporting files here are basically the versions.tf and the providers.tf and the terraform.tf_vars file, which is variables file. Okay, and also a readme document. So here in this document, I kind of gave a clear instructions on how you can also do this all by yourself without even watching this video. Okay, so let's start with the supporting files. The main supporting files here are three. One is the versions.tf, where I am declaring what is the Terraform required version, and also what is my cloud provider, and also the version of it, supporting version of it. Apart from that, I just put a region as US East 1 in providers.tf file. Okay, so let's coming to the tf_var file, which is basically here all I'm telling you is how to customize this whole sample repo as per your needs. So if you change these things, like for example here, org name, you can put your own name here, team name, TF project ID, it could be anything, the region, and environment, the dev and QA, and all these stuff which you could customize by yourself so that you don't have to change majority of these TF files in it, right? So I don't have to tell you what is the benefit of having a variables, putting these things, because we are learning the advance of how to implement modules, right? So let's go to the actual main.tf. Before we go to the main.tf, let's go to the variables.tf and see how does it looks like. So here I'm just putting the variable type string, team name, project ID, environment, and also few other stuff which we are required to have in our code build project. All right, let's go to the main.tf. So this is very important to understand the main.tf here, because ultimately this is the core for calling all other modules. Okay, the modules that we wrote here in code commit, code pipeline in ECR, this is the main file which gonna call all these modules. So if you see here, all we are doing here is I'm basically creating a namespace or creating a generalized name, which I could use that name across creating all my AWS resources. Well, I kind of created three different names. The reason why I did it is one, environment namespace, which I want to use it if my resource is environment specific. General namespace if my resource is in general namespace. So example, another one is S3 bucket namespace, which is mainly used. The only difference between this one and other ones is, as you know, in S3 buckets, we cannot create a resource of S3 bucket using underscores. That's the reason I put a hyphen here. Otherwise, it's pretty much same. And all these values are coming from our tf_vars file. Let's go into the modules. So here I am calling out a code pipeline module, and I'm telling where is this module is, which is basically under my modules folder, which is code pipeline, and I'm feeding the data. I'm feeding the values for this code pipeline module. Okay, and what are these modules? Where are these being declared? Basically, my code pipeline has a file called main.tf, right? This guy. So the logic that is sitting here is expecting that whoever is calling this module is required to feed these data to this module. So that is the reason we are already including in it. So in this example, what we are doing is we are generalizing we are feeding all the data, general namespace, environment namespace, S3 bucket, and code commit repo, which we are calling from another module called module.codecommit and code commit configs. I'll walk you through where is this whole thing coming from. But for now, take this way as this is a module which is required to feed these particular values to it. Then only it will function. Right? So let's go to the code commit module here. In a similar way how we have designed our code pipeline module, I am calling out this module saying that, hey, code commit, take these variables and create a resource for me. So what are the variables? General namespace, environment namespace, and code commit branch name. Same goes with the ECR as well. Hey ECR, take these two information and create a ECR repository for me. Right? I hope you are clear about how I'm declaring, how am I calling out the modules in the main.tf or the root terraform folder. Okay, now we have some understanding about this particular stuff of main.tf file. So let's go into a supporting modules of code commit and ECR repo first, and then finally go into the code pipeline. So the ECR, obviously we need somewhere, some place to push our container registries, right? Push our container Docker images, right? So this is where we are doing it. So our code build has to push our Docker images to the ECR. For that, we are creating the ECR repo here. All right. Remember what I was telling you about general namespace? So this is the reason why I'm creating those namespaces at the main.tf of the root folder, so that we don't have to recreate a different namespaces or name standards for each module. So all I'm doing is just adding an additional variable, additional data to it, so that it will become a unique resource ID. So here, general namespace underscore docker underscore repo. That is my repo name. And I'm just also for the best practices purpose, I'm also adding a tags to it. That's it. So let's go to the code commit repo. Here as well, so the same thing, pretty straightforward. This is I'm calling out the code commit repository, and then feeding the data here with the repository name as this, and the default branch from this one, and also having a brief description of what is this code commit repo is. All right, let's go to the outputs folder and see what exactly it is. Okay, so I'm gonna split the screen into two so that you would understand the difference, why I'm putting this one and where is this being called in our main folder. All right, so this is my terraform root main.tf file, under which in the code pipeline section, what I'm doing here is I am for the code commit repo, right? For these two variables here, code commit repo and a code commit branch, I'm telling that modules.codecommit.codecommit right? So this is exactly where that configuration is coming from. So I am from the module of code commit, the outputs of code commit configs, and the variable here is repository name, which is this one, and the branch is this one. So now do you understand how is it being connected between modules to modules? So same case is going for the ECR repo as well. So let me pull up that one. So ECR outputs. If you see here, this is my output file for ECR repo. So same thing again, for ECR repo on modules.ecr.ecr configs, which is here, and then ultimately ECR repo on this guy, right? So the output of my module ECR would be feeding into the input of my code pipeline. I hope this is very clear for you. The same goes here. All these are variables required for me to create a code pipeline, right? Okay, so let me close this split window and then go back to our code pipeline main.tf. So the main.tf basically required to have the code pipeline required to have a code build project, right? And there are two stages for the code build project. One is the build stage, other is the deploy stage, right? For that, all I am doing here is creating two projects called the namespace projects count of index. The count of index is basically coming from these two, which is 1 and 2. So the first code build project 1 and the second code build project would be 2, right? And here I'm calling out a service role, which is AWS IAM role, lambda code build role on. So where is this guy coming from? So there is a roles file in codepipeline modules. So this is the file which I have separated out from the actual codepipeline module, which is basic from the main, so which I created out separately so that it's easy to manage all our IAM roles in one Terraform script, which is I'm creating a lambda code pipeline role, and then lambda code pipeline policy, also lambda code build role, which is used to while using a code build project, and lambda code build role policy. Okay, so let's go back to the actual code pipeline main.tf again. So this is a service role which I'm being created, and I am feeding this information. So how does my compute looks like for code build project? How does my image, what is the image of the code build? What is the type of the code build? And all this data, imagine all this data which is coming from our main root tf.vars file. See here, build general medium. This is my code build type, compute type, image, and code build type, and of course a code commit branch name. So all these variables are being fed to the code pipeline main.tf file. And also I added a dynamic block here, which is basically helping me to trim down the list of environment variables that are required for me to feed it. So where are this stuff coming from again? So let me show you that. Here, for each var.build args, right? So this is var.build args, and if you see the variables here, so for all the variables, so if you see here, there is a separate one called build underscore args. So for each var.build args, the content is environment variables dot value dot name. So it is basically feeding that data and dynamically creating that information. So it's going to loop all that variables from the variables.tf and add those variables to it. So if you see here, variables, environment variables, right? Okay, so now let's go to the actual code pipeline resource. So here, all I'm doing is just calling out 3 stages. Stage 1 is a source of what is my source and where is it coming from. And number 2, a build stage. Remember that first stage that we want to compile the Docker file and create a Docker image and push it to ECR. That is the first code build project. And 2, the deploy project, which is basically taking that same Docker image and provisioning our AWS Lambda code. All right, I hope this is clear for you. So let's go into the action now. Let me pull up AWS credentials and make my terminal ready for trigger this Terraform code to provision the infrastructure in AWS. cd terraform and do a terraform init. All right, let me clear the screen. Okay, after doing terraform init, let's do terraform validate. Okay, configuration is valid. Now do terraform plan. All right, so let's do terraform apply now. And do yes. All right, congratulations. So we have provisioned our code commit repo, code pipeline, and ECR repo, right? So before we check out our code to our code commit repo, let me walk you through the code build projects. How does it looks like? So in the Terraform modules code pipeline, there is a templates folder here. So under this templates folder, you'll be seeing two files. One is the build spec build and the build spec deploy. This is for the stage one, where you're gonna run the Docker image and push the Docker image to the ECR, and two, build spec for the deploy. Basically, this is one which you're gonna log into the ECR and apply Terraform commands, Terraform init, Terraform validate, and Terraform apply. Pretty much simple. Well, there are so many ways how you can do these things, but for this demonstration, I kind of kept it very simple so that you would understand how you can provision, how you can do modules. But is there a better way to do your provisioning of infrastructure using Terraform through pipelines? Yes, there are. So in this section, we are just going with the very basic steps. I hope you understand very well. All right, let me take you to our AWS console so that we'll also see our code pipelines as well. My AWS console, and I am in the code pipeline section. I refresh my code pipeline for page, and this is the code pipeline it is. So I clicked on it, and if you see here, for the first time when you provision it, obviously, since we haven't checked in our Lambda code yet, this is the source stage where it stopped failed, right? So in this pipeline, you'll see a source stage, a build stage, and a deploy stage, right? So let's quickly see what is the error. So AWS code commit branch master does not exist. Of course, we haven't created any of the branches yet. So we'll be doing that in the following sections. So before we do that, I also wanted to walk you through how does the ECR looks like, the container registry. So it has created a empty container registry in it. So once the code pipeline executes, you should be seeing a Docker image here, right? And also, let me go through the Lambda function. So as of now, the Lambda function is empty, right? Because the pipeline obviously didn't run. So once this is executed, you will see a Lambda function here. All right. So all these things as of today, all these things as of now are completely depend on the pipeline to be executed. So before we start executing it, let's create a code commit. Let's commit the code. So before committing the code, we just want to check whether the repository existed or not, right? So let's go to the repository. Here we have a repository which was created 9 minutes ago, right? And this one as of now is very empty. That's the reason you are seeing all this stuff. So if you're creating this repository for the first time, right, you make sure you have your Git credentials associated with your AWS console access role. So what I did is I went to the IAM, okay, and I clicked on the users. This is my username, right? And if you see here security credentials, this is my access key, and there is no AWS code commit key here. We don't need it. However, this is what you needed: HTTPS Git credentials for your code commit. So you basically need these things. This is my username, and the password is where if you don't see this one when you open your user or the role that you logged in, make sure you generate the credentials and download a CSV file, and based on that file you configure your VS Code editor to authenticate your Git repository. So what is the Git repository here? Remember, I showed you when we are doing the AWS command outputs. Let me show you that again. Right. Remember when we applied when we did a terraform apply command, this is the output that we got after the infrastructure has been provisioned, right? So all we need to do is, once you have configured your HTTPS Git credentials from AWS console, all you need to do is go back to your root folder, clear the screen. Now I'm at the root folder. Then do cd git clone. Okay, so when you're doing it for the first time, and if you have already configured your Git credentials through your VS Code, so congratulations, you have successfully cloned the empty repo. Now, the key thing that you need to do here is move the lambda bootstrap folder, or copy the lambda bootstrap folder to this folder. For now, I'm just doing it manually, but you could do whatever the process that you want to do. So all I'm doing is selecting all the files from this repo, from this folder. Command C, I'm doing Command V. That's it. Right? Okay, so I just did a copy of lambda bootstrap folder, contents of the lambda bootstrap folder to the cloned repo. Now, clear. Let me go to the actual repo that we just cloned. cd clear. Now do a git status. So all these files were added. Just do git add git commit -m initial check-in and finally do git push. So let's go into the actual code AWS console and refresh our pages and see if the code pipeline has already started or not. Oh, there you go. So once you push the code, our pipeline automatically triggered. So it checked out the code. Now it is doing the Docker build. So you could click on it and see what is the progress of it. Good. So now let's go back to the pipeline again. It has completed the second stage. Now it is going to the third stage. So while this is in progress, let's go to the ECR and see and do a refresh. Yay! Congratulations. So it means that we have pushed our Lambda code